Hey everyone, welcome back. So our next presenter will be Neil Cherry. Neil Cherry is a quality assurance engineer with Tech Mahindra. He has AS in electronics and a bachelor's in computer science and information systems. He's also a deconstruction lab board member and is the author of Willie's Linux Smart Homes for Dummies. He has been working with computers, computer electronics, and software since 1978 and has been playing with X10 since 1982 and began automating his home in 1992 when a friend gave him an X10 computer interface. And Neil has started the Linux Home Automation website. So without further ado, can you help me please introduce Neil Cherry?
Okay, hello there, folks. Can you hear me?
Yep, we can hear you.
Okay, good. Wanted to make sure I was unmuted on all these things. All right, folks. So here's what we've got. The originally titled "A Funny Thing Happened on the Way to the Quorum." The switch over to Zoom has made it so that all the interactive stuff is now is kind of gone, and I have no way of showing it. So I'm afraid I'm stuck with slides. So I've reorganized the slides. Hopefully this will work out well for us. Okay. The QR code that's there, that will take you to where the presentation slides will be. They're not there right at the moment because I had to juggle these around. So I was kind of working on them till this morning. All right. Now this is one of my cute things I always start off with, which is somehow I don't think you thought this cunning plan all the way through. This is AC power. I want you to be very careful with this. This can kill you. Okay. If you're not comfortable with playing with electricity, where you have to rewire things, make sure you get an electrician to help you out with this. Things will be okay then. There are a lot of devices where you don't need to rewire anything. A lot of outlets and stuff, so that will actually make your life a lot easier. But if you're talking about rewiring an outlet or a switch or some kind of a socket or something, if you're not comfortable, please get an electrician. Okay, let's see. All right, this is one of the basic modules from Sonoff, and this is being reprogrammed. And what we have here is just simply the Sonoff itself and a USB cable. You plug it into your laptop, you do the appropriate download of the code, and everything works fine. Do not plug this into the AC outlet while you have it plugged into your laptop, because you let the magic smoke out. Okay, it could destroy your laptop. These things are meant to be programmed if you're going to reprogram them via via that USB cable. In most cases, the USB cable will provide you with enough power to power this to be reprogrammed. Okay. Not all these devices need to be reprogrammed. It's just that some are there. All right. So my introduction already said, so I'm going to skip this. Okay. I have a makerspace down in Wall Township. In a few months, I will have a presentation of all this interactive stuff that I was going to have here. I will have it there. Okay. I will announce it on the the website, and this QR code here will take you to the website. Let's see. Now, this one, I love this quote. It says, "I've always liked the idea of Internet of Things, but in practice, it's too close to a Cory Doctorow novel. Imagine your phone tracking your Strava runs and sending it to your healthcare provider, letting them know you've not been for that run that you promised. You were going to go on, that you were going to go on. On the online service, being able to manipulate the price of cream to make it to, sorry, I have a dog next to me who is interrupting me, and he's poking me. Sammy, go away. With a load of strawberries in your fridge, you can imagine they're going to be manipulated. Anyways, it could be excellent, but the future, unfortunately, has been hijacked by a couple of big companies that depend on advertising revenues. This is why we can't have nice things unless we make them ourselves. The smart fridge in issue 43 10 IoT projects, page 47 of the Hackerspace magazine, is a perfect example of what we could and should have. And this actually is a very good quote because it brings up the problem that large corporations, they're not really interested in you as a customer as much as a consumable product. Okay, so your privacy, they sell that. All right, so here we have the minimal setup. We're back to the Sonoff. You can actually buy a Sonoff, okay, and not reprogram it, plug it in, download an app, and you can then use it directly, okay? Turn things on and off, all you want, okay? Or you can reprogram it, all right? And then with the Tasmota code or some other similar code, you can then download, you can interface to this via your web browser, which means that you can use your cell phone, you can use your web browser, and it is not in the cloud. The original code, it goes into the cloud, which means that you send your information up to wherever the cloud is, okay? If it's hosted in the United States, China, Europe, Asia, South America, the South Pole, you never know. It goes up into the cloud, comes back down, and turns on the thing. Seems a little idiotic on my part, but you have to have an internet connection for this thing to work, okay? If you're doing it by yourself, you've reprogrammed this, you're local. It's not going out into the cloud. The internet goes down, you still have control of this. There also is a manual button, which is a little hard to see. It's a little black stem that sits in the middle. Okay. Winking, blinking, and nod. Okay. What's up with about the hubs? A lot of the services that are available right now, the hubs themselves, you can buy them, okay? And then you use the cloud service. This is an example with the smart things. There's also others such as Wink, who went out of business, okay? Which brings us to the next part, which is a lot of things go end of life, okay? Especially with commercial services. Wink went out of business because it wasn't making any money. Several other vendors also went out of business not making any money. Samsung, who now owns SmartThings, seems to be making money at this. How, I don't know. Probably selling, your private information or using AI on whatever you're doing to figure out some new revenue stream. All right. But that particular smart hub, the first instance of it has gone end of life. So if you have one, it's no longer supported. The second version and the third version are. You can usually buy up and buy a new one and continue to use the service. Okay. The Alexa and the Google Home, those aren't exactly they aren't exactly hubs. They're voice assistants that can send out some information, but they generally don't have things like the Wi-Fi. Excuse me, they have the Wi-Fi, but they don't have the Zigbee or the Z-Wave. On the right-hand side, on the left-hand side here, we have a Raspberry Pi, and there's a little dongle plugged in. One is a short dongle, the other one's a long dongle. They're basically the same thing. That turns your Raspberry Pi into a hub. In this case, this one happens to be a Zigbee interface, but you can't tell by looking at it. When you buy it, it'll tell you which particular interface you use. Okay. Now, this was actually going to be one of my demo things. Okay. And what we have here is a rather complex demo board that I've put together, and I'm going to try to explain it. Right? If your eyes drift down to the bottom, you'll see the letter G. That is an outlet. It's simply a Wi-Fi outlet. You plug it in. I've reprogrammed it with Tasmota. The brown cable goes up and behind. I've hidden the cables, and it happens to connect to light A. Okay, light B happens to be connected. Happens to be connected to device R, okay, which is also along the bottom. Light C is connected to the basic Sonoff, the letter F in the middle. And I showed you one of those open earlier on. Okay. Light D is connected to the big square box up in the right-hand corner. That is a 4-channel. Light E is also connected to the 4-channel. There's also K and L. Those are also connected to the 4-channel. And then the rest of the stuff that's there on the right-hand side, you've got a light blue box there. That M, that's a wireless AP. It's meant to be taken with you for traveling whenever I go to do demos and stuff, I can't guarantee that I'm going to be able to get onto their Wi-Fi and use all of this stuff. So I've got it programmed everything here to talk to that AP. Next to it, we've got a Raspberry Pi. Okay, that's running Linux. Right, it's got all my software on it for automating this, and this would have run and turned lights and blinking on and off to make sure everything was working properly. The black box that's sitting behind it is an SSD drive. I've put everything on the SSD drive rather than keep everything on the SD card. They last longer and they're more reliable. Although, having said that, the last SSD drive I had failed last year after being plugged and unplugged a million times, so it didn't like the abuse. Okay. Q just happens to be an set of outlets. It happens to provide USB power that I was using for the AP, and it was providing USB power for the Raspberry Pi. I've since discovered I need more power for the SSD, so I've had to put in an extra power supply to handle the Raspberry Pi and the SSD. Down on the bottom, the S, it's just a dumb power strip. Okay, that's all that is. Okay. Now, what is home automation? I don't have a good explanation for you anymore. Okay, it used to be we had a good description of this, but nowadays everything that we're doing, it's more like a personal assistant. You know, it's more personalized things that you would need. The weather service. You can get the information to your phone. But you can use that information in your home automation so that you don't water your garden that day, or you know that it's going to rain, but only a little bit today. So you will water the garden even though it's maybe raining. These are the things that you can figure out. One of the things I do is that I like to go riding down in the Pine Barrens. One of the problems I have is I'm asthmatic. Okay? The ozone that's produced in the Pine Barrens can be quite severe. It can give me the equivalent of a sunburn in my lungs. I have information which I'm pulling from New Jersey air sensors that tell me the quality of the air down in the Pine Barrens. All right? I can get that sent to my phone. I can also get weather reports such as tornado warnings. You get some pretty nasty thunderstorms in the Pine Barrens. So this will allow me to take that information and do certain things with it. Right? Now, so why the title? Now, Herb's going to get a kick out of this because I saw that he's on. He challenged me one day, and he said his view was that DIY home automation is dead, which isn't really true. Right? You can't buy the stuff in the store so much anymore, although I did notice Lowe's does have some. Right? But it's become such a rather complex subject, all the DIY stuff, that you have to buy it from the individual manufacturers, such as Sonoff, such as a company called Tuya, okay, which I believe you can get through AliExpress or Banggood, okay, which is not my favorite way to buy things, by the way. And it's also not just about home automation. It's also about other things that we're pulling in. For instance, the New Jersey air quality. I found that online, and I was able to scrape the information off their website. Right? While discussing this with a colleague, I discovered that I confuse people. I make assumptions that everyone understands certain things, and I'm going to try to take care of that today. Okay. Why can't you buy this stuff in the store? Well, it's too difficult to buy this stuff because you buy one little piece, you try to use it, you can't figure out how to plug it in with something else. They don't play nice together, although Matter is supposed to take care of that. I won't be able to cover that today because I really don't have a lot of details, but it is the higher layer which is allowing things to connect together more easily. I'm not sure if it's stuck in the cloud or whether you can use it from your home. Okay, so that's one of the reasons why I'm really not going to cover it. Okay, one of the things is that Rome is not built in a day. This takes forever. This actually has been going on for at least 20 years with X10 starting out, Insteon, and everything else. We're getting to the point where this is starting to get closer and closer to actually being able to build it. All right. Now, the thing is do you want to build the home automation from scratch? Okay, do it yourself. If you want to keep out of the cloud, you do. If you don't mind using the cloud and whatever they're doing with your information, you can buy this stuff online through, for instance, SmartThings. You can buy the various Wi-Fi devices, the Z-Wave devices, the Zigbee devices, and you can go online and you can plug them in. They're still a bit DIY in that you're going to have to program them. Okay. If you definitely don't want the cloud, there are alternate ways. If you're going to do that much programming, you might want to consider not doing it in the cloud. So let's see. Okay, typical high-level view. Okay, the Wi-Fi in the center is just simply the waves in the center is just your Wi-Fi AP. Okay, and all the devices here I'm using are Wi-Fi. It could be Zigbee, it could be anything else. It's just an antenna. As long as you have the dongle and you have the Raspberry Pi talking to it, it can control things. All right. But here we've got is a Raspberry Pi, some ESP devices, which those Sonoff devices, they happen to have an ESP chip inside. So I labeled these ESPs. One of the goofier things I have is a traffic light in here. I built a traffic light on a breadboard. All right, red, yellow, green LED. It goes through and cycles through. The home automation is actually controlling that, plus monitoring a sensor, plus monitoring a button. The little black box on the right-hand side in the middle, that's your web page or your cell phone, controlling things if you want to manually control things. Alexa can get involved with this. On the left-hand side, I have a smart TV, but in addition, I have a little black box in the middle, which is an IR controller. You can send information to it, and you can receive information from it, so that you can manipulate the controls of the TV. For instance, you can use your remote. The little black box in the middle can receive the IR, and then not only will it turn on the TV, but it'll turn on the appropriate stereo and whatnot. It may even go as far as dimming the lights. It may control your curtains, depending on what you're doing at the time. The device on the very left is the internal guts of a fancier version of the IR controller. All right, that one allows you to do a lot more than the little black box in the middle there. All right, so this is just a general view. You've plugged in a bunch of stuff and you want it to control, and Raspberry Pi is doing your control because you're keeping the stuff out of the cloud. All right, so now a little hardware to start off with. Okay. So I'm recommending a Raspberry Pi. You can actually use a PC if you want something, if you want to use your PC. If you can't get a Raspberry Pi, this happens to be running Linux. We put Linux on there. You can put Linux on just about anything. Then the extra software, most likely it's going to run on there. It runs on just about everything. Underneath it is a USB dongle. Okay, and I just call it a dongle because I don't have a better name for it. This could be Zigbee. It could be Wi-Fi. It could be IR. It could be your a software-defined radio, which picks up signals from your weather stations that have the cheap RF little things that they're, the temperature gauges and whatnot, the wind stuff. Underneath is an ESP. Now this one happens to be an ESP8266. It could be an ESP32. It could be several other things. This is from Adafruit. These are programmable devices. These happen to be the chips that are used in the Sonoffs, and they're the ones I'm mentioning the most. So you can build your own, but the same code that's used in building your own is also controlling the Sonoff devices, which you can get ready-made code for downloading. Now, the home automation stuff on the right, this is the stuff you can actually buy, and you can buy it from Sonoff. And I'm using the Sonoffs because this stuff generally looks like everyone else's, okay? And, okay, so we have our regular outlets. You plug it in, plug your device in. You can manually control it with the circular button that's there. You can control it with the Raspberry Pi. Underneath there is a square box. That is a two-way device. If you have any two-way switches in your house, right? You put this in the middle, you wire it up appropriately, and you can control the outlet with the two-way switches and with your home automation, and you won't interfere with the two-way switches. I just got those. I haven't plugged them in yet. I have a lot of steel boxes. I'm wondering how this will work on there. Up in the right-hand corner is a 4-channel. This is a little tough to wire, but it allows you to control four different devices for on and off. Underneath is a thermostat, and I just bought one. I haven't installed it yet because I have electric baseboard heating, and I went and looked to see if I can buy some more online and discovered that the supply chain issues, they're back ordered. Okay, so there's going to be a while before I get there. Underneath is the Sonoff. All right. Now, these devices in the big white box, these are things you control or you monitor, okay? Because these will provide you information, how much power it's using, whether it's on, whether it's off. So you can use these And you can use these so that if you hit a button on one of your outlets, okay, that turns on the light locally, it can also tell the rest of your home automation, oh, if you're going to turn that light on, you want all the rest of the lights in the room also on. Okay, so you don't have to rewire everything. It's a great way of doing wiring stuff without actually having to do the wiring. All right. Now we get to the software. Now, MQTT, this sits in the middle. And I will explain why I'm listing these little things later. You use these all to put together. But MQTT, it sits in the middle. Okay, it's a broker. Okay, it's a message broker. And all it does is just sit there and allows you to publish messages and subscribe to messages. And I will explain this entire diagram a little bit later on. Now, the green box here, this represents the Raspberry Pi. Sitting on the Raspberry Pi, okay, is Linux. Okay. Under Linux is some software programs. One of them is called Node-RED. Okay, it handles flows. I'll explain that in a minute. And MQTT. These are services that are available. Right. The Node-RED is doing all the control of your house if you've only gone this far. I'll explain later. I have some more software to show. Right. And MQTT is just sitting in the middle. You don't have to use this. But one of the nice things about MQTT is that it allows multiple things to do the publishing and subscribing. Okay. Now, like for here, I have a bash command line, okay, which people hate. All right. I use it all the time. I write scripts. I manually type in things. I get it to go and run things. Okay. I have an ESP chip down here that's controlling a light. All right. And I can send various commands. I can send it from a command line. I can have it automated from Node-RED. I can have other scripts that are getting involved. And then the toaster and the radio, I'll explain those a little later. This was initially part of my interactive stuff. Okay, so I'll get to that in a minute. Okay, so message MQTT Broker, right? MQTT sits in the middle, okay? It is a network service. It's just software, okay? Its job is to accept messages from publishers and send them to their subscribers. It's kind of like a magazine service. Okay? It does this with topics which kind of look like system paths. So if you subscribe, if something subscribes to a topic, okay, anything that's published to that topic, it will get. Okay? Devices can either be, they can be publishers, subscribers, or both. And they can do it to multiple topics, depending on how much resources that you have. Little devices tend to have only a few small topics. Raspberry Pi could subscribe and publish to all of them. Now, what I'm showing here is the Internet of Toasters. Okay, and this will make more sense a little later. The interactive show would have actually made this more sense then. This happens to be Mosquito sitting in a cloud. Okay, it can also feed to a database. It has a database built into it. Here's another cloud service that actually talks to MQTT. And here we have MQTT talking to another MQTT. So you can actually have these all over the world and have one toaster in one part of the world actually talk to another without actually having the toasters talking to the same MQTT. For the simplicity of today, we'll stick to one MQTT in the middle, okay? And the reason I'm using the Mosquito is that's what it's called, the software. Okay. So I think I've explained that good. Here we have Node-RED. Now I'm going to show you a very, very complex version first to show you what it's possible to do. All right. This is a web interface. What it does is it goes out, it gets information from Mercer County Airport. It gets its META information, which is a standard information that the airports use to tell you about the weather. Okay. This goes through, it processes the information, and then it publishes to this page. And at the moment, these two gauges are down because I have the traffic light is not up. Traffic light would have provided the temperature and the humidity, but when I was doing this, I think this was last night, I think I grabbed this from, Friday the 18th, yep. It was 50 degrees. It feels like it's 49. Humidity, dew, pressure, visibility. There was fog last night. the wind speed, okay, the wind direction. Okay, we were connected. We got VRF, which visual flight rules, I believe, and fog, and we can display it in other different methods. This is just a battery down here to tell when things are, how much charge something has. Okay, so as you can see, you can get the information and then you can display it in something that's quite understandable. Now, here's a much simpler one, and the reason I'm showing you this one is because this one's actually quite useful. All right, this is so I can publish my tweets from the command line. I have scripts that actually grab the information from one place, put it into another, and then publish the tweets. And I can either publish to the computer deconstruction lab, to its account, or I can publish to my Linux HA home automation stuff. Right. Now, the way you do this is you go and you find your appropriate nodes that you're interested in. Each one of these is a node. Okay. This whole thing is called a flow, by the way. So you grab a node out of the node list over here. Okay. The purple ones here happen to be Mqtt in. Right. Drag one, you put it over here. You take your tweet. Okay. So you're going to output a tweet to there. You put one over here. You then connect the wires between them. I'm adding a debug node. Okay. So I put a wire from here to here. So now it's anything that comes out of the CDL tweets topic in Mqtt. I can see it in my debug logs, and it'll be published to Twitter. Okay, so I double click on Mqtt. I set it up for the topic that I'm interested in, which server, the information will be in there. I put in over here. I double click. Whoa, sorry about that. I double click on the tweet node, and I put in my login information and a few other things. And then I publish this. Okay, there's no publish button showing here, but I publish this. Mqtt is ready. I can then send tweets without having to log in, and you know, usually with your phone you have to log in and do all that kind of stuff, right? So I can do this through an automated method. Okay. Now, and here we go. We're going to put it all together. So, using Node-RED, Mqtt, and an ESP32 with Tasmota firmware, and a web page, I'm able to create automation based on the time of day, events like weather prediction, or input from a browser to control lights, in other words, manual. I can monitor devices, and I can use Node-RED to display the information as the gauges. I've showed you that. And or to use the information to control devices. Because I use Mqtt to send the messages, weather, temperature, on, off, and because Mqtt allows multiple subscribers and publishers, I can manually or programmatically use the information in other ways, such as shell scripts or smart home software, which I do have Home Assistant later on I will show a little bit about. Okay, I currently use Samsung's SmartThings with my Node-RED flows. I use shell scripts, I use Python scripts, and I use Home Assistant, which I only just started with, and it's driving me a little nuts, but I can turn things on and off with the Home Assistant. Right, and this is what I'm using in my home. Okay, now, the Internet of Toasters. Those familiar, this is Talkie Toaster from the British TV series Red Dwarf. Okay, it is a very annoying toaster which has only interest in making toast. It is an artificial intelligence that has an IQ of like 9 billion or something. It's a ridiculous number. Okay, it is, but its sole purpose in life is making toast. So that's all it is interested in. Okay, so the operation of Talkie Talkie Toaster and Talkie Radio. I built a radio that actually talks. Okay, I use Impress. This is the presentation software that I'm using now. You could use Microsoft's presentation software also. Okay, it executes a script that tells Node-RED to coordinate the conversation between the toaster and the radio. The toaster would be using lines from Talkie Toaster. The radio would have had Lister's lines, his complaints about the toaster and stuff. So It was actually quite funny. I really wish I could have shown that, but unfortunately I can't. Okay. The radio and the toaster, just simple Arduinos. They're ESP32 sketches that run that tells it to run a MP3 that's stored on an SD card. Right. The sketch also listens to MQTT topic and returns the status of where each one is, so that Node-RED could coordinate, when to start the other party in the conversation. There's also a little bit of random lines because in the show, Talkie Toaster pops up all the time asking stupid questions, okay, which related to toast. So it would do that, and it was going to do that in my presentation also. So now we have Home Assistant. Okay, Home Assistant is a rather big Python program that's now sitting in several Docker containers. Right, it's quite complex. It can do a lot, and I haven't quite figured it out. In fact, I'm wrestling with it because it's too intelligent for its own good. It learned a bunch of stuff, and I couldn't tell it not to learn it. But basically, here's what I've got. It learned about my Roku sticks. It learned about my Google Home, which I put in the dungeon, and my one in my living room. Okay. As you can see, the living room has a whole bunch of switches. Actually, this is one switch that has a whole bunch of features built into it, so it takes up everything. And here we have my bench lamp, my carousel lamp, the weather report, okay, the current version, the season, the TV lamp, uptime. One of the devices, this one happens to be unknown at the moment. I have it unplugged, okay? And here's a list of all the stuff. Okay. Now, this is one of two instances of Home Assistant I have. Here's the part that kind of surprised me. As I was copying these over, I just found that a new device was discovered. Okay. And what it found were my two instances of Octoprint. I have Octoprint for my 3D printers. I didn't even know this was going to happen. So it went out and it found my Octoprint. As you can see, it also found my Google Cast devices, the weather stuff, my local MQT of Roku, one Tasmota device. I have dozens of them, but I can only found one. And the reason is that that particular Tasmota device happens to have the latest code. Now, let's see. Okay, so here's the second one, but this one happens to be in dark mode. It'll have the same information that was on the first, just happens to be formatted differently. Okay. Here's a sample of Home Assistant that somebody else has in a different part of the world. One of the reasons that I like Home Assistant is I can take my ESP32 cameras and I can throw them in here and it will interface to them. But not only that, it can also throw in some AI software like TensorFlow, and I can use it so that it can use the cameras to identify things, which I can then use to control things around the house. For instance, if you walk into a room, if a human walks into a room, the TensorFlow will determine it's a human and turn the lights on. I have two dogs. I don't need the lights being turned on when the dogs walk into the room. It's really not going to help them. Okay, here's another view. They have the floor layout of their house, which I'm also very interested. Plus, they have their power distribution because they have solar. All right, now security. This is one of my favorite pictures. This is a botnet that was used in 2016 to attack Brian Krebs, a security journalist. Okay. Apparently, Brian Krebs ticked off one of the botnet owners, and they used it to generate a 280 gigabit per second flood of his websites. He mitigated it. Not sure how, but that was some really good work. So if you're doing anything in your house, secure it. Okay, use good passwords. Don't use the default stuff. Now I'm going to see if I have any questions with all of this. I do apologize. I have been flying through this. Let's see. All right, the interface on the two-way switch. Okay, the interface on the two-way switch is your actual two-way switches. Okay, or it is a particular topic in MQTT that your Raspberry Pi can control, and it's simply turning it on or off, okay, without changing the switches. So a two-way switch is simply one is on, the other is off, okay, and you're never really sure which one it is. If you walk into a room and it happens to be up, which would look like on, you would flick it down and whatever light you're controlling would turn on, right? The other side is now also in the same position. If you walk over there and you flick it, it'll turn the light off, okay? The little device is wired in the middle of this, okay? And what it does is that it acts like a third switch, but it doesn't interfere with either the first or the second switch. So you can continue to use those, and you can have this in the middle, which means you can then turn things on and off manually, or you can turn things on and off automatically with your Raspberry Pi, Node-RED, or Home Assistant. Okay. Any other questions? Because I can actually go on for, I have a couple more slides, but I don't know how much more time we have.
Leaves the wires straight through or crosses them over based on whatever you send to the doohickey?
Yeah, it takes the wires that are originally, okay, this is a little, you need to look at the diagram. It actually explains it quite well. Right? You hook up the wires appropriately, right? And it's actually going to be sitting in one switch or the other, right? Because you have all the wire in there. It's not actually going to sit in the middle, right? And what it does is it allows you to mimic one of the switches, right? And it's going to treat the existing switches as something telling it what to do, right? So when you flick one of the switches, the little two-way box is actually going to set the appropriate switch, whatever it is, to turn on whatever it is or turn off whatever it is, depending on the particular state that the thing is in when you flick the switches. Did that answer your question?
Does it report the state of the switches?
Yes. Yes. And the power usage. Okay, some of them report the power usage. Some will not. There are, for instance, the outlets that you can buy. You can buy an S26 Lite that does not have the power reporting. But if you buy the S26 without the word light, it has the power reporting. And the Node-RED can subscribe to that topic, okay, and put it into a database, or it can put it into a graph, like, was it shoot, I've got so many databases stuck in my head right now. There's a database for real-time data, and it'll graph it real nice for you, telling you, how things were used, and you can do analysis and stuff on the database information.
Okay, and so another question, and I don't want to monopolize all your time, but
No, keep going. I'm
wonder
happy to
if you can help me understand this. So you mentioned Node-RED, and you mentioned a separate broker, a message broker, and also that other home automation mechanism, the name of which I forgot, but I've seen it before. That kind of centralized, yeah. And so that stuff seems like awfully heavy weight, and it would seem like it has the problem that it does stuff that maybe you don't want it to do, especially the Home Assistant part. Is it possible for you just to, write a bash script if you want to turn on a light that sends a message to one of these devices without without these intermediary brokers? I mean, can you just open a TCP session, like a telnet session with Tickle TK or something like that, and send it the right magic and turn it on and off and stuff like that? Or do you really need these brokers?
No, you don't need the broker. Okay, you can have, going back to the simplest setup, and I'll just use this one, okay? All right. Basically, okay, if this were closed up and you had the wires in it and everything, you've got it programmed, It has a web interface. Okay, so you can technically send REST, via the REST, an HTTP request to it to turn on or turn off, or to give you the information. You can query it. All right, it just happens to have MQTT also. If you program it for the MQTT, it will publish that information automatically. All right, so you can start off real simple, buy one of these. Okay, you buy a dozen of them if you want, and just simply have simple scripts. Right? That is exactly how I started when I was doing this stuff with X10. I was just publishing. I had a TCP daemon that would interface to a CM11, which was RS-232 device to X10, and I would send X10 commands. When I got later on, I got the Insteon interface, and then later on with SmartThings, I was a little overwhelmed with SmartThings, and I was a little underwhelmed with SmartThings because they gave you boxes. Okay, everything was in boxes. These little. You looked at your cell phone. It's in a box. Okay, you press the button. Okay, and it did its thing. So I put it into stuff that would be automated. Okay, cron jobs would run. It's just shell scripts that get sent, that send the information to MQTT to publish. Now I could have done it directly, which is what you were suggesting, like with Pickle. Or with Python, or with Perl, or with Bash, because you can use the MQTT clients, okay, which are just commands in Bash, in Shell, right? And you can send to the appropriate commands. I can even use curl, okay? Send it the command, okay, and it will turn on, it will turn off. I can query it for the information. You can make it easy. You can make it simple, the bash commands, or you can make it complex, or anywhere in between, or you can have both. In other words, you can actually control this stuff from the bash while using Home Assistant and using Node-RED, or just from bash. You can grow this as you go along.
Thank you very much. And there's another question somebody's posted in the chat.
Oh, okay, I see.
So really quickly, I just want to mention that we do have until 1:20, so we have around 13 minutes if you want to, if you have additional things that you want to present or you want to continue with the time of questions, that's totally fine as well. For people that are wanting to ask questions using the microphone, I just ask that you use the raise hand feature. It's found in the reactions button down at the bottom. And then aside from that, you can also post your questions in the chat. So go ahead.
Thank you. Okay, let's see. Okay, so, oops. I got a couple of them here, and it scrolled away on me. Okay. Does my demo system have a name? Yeah, it's called Demo System. I'm not kidding. It's just my demo board. It uses a Raspberry Pi. It uses Sonoff. It's Wi-Fi, which is why I have an AP on there. Okay. Because if you're going to demo, you bring it somewhere, you can't reprogram all those devices to use whatever Wi-Fi is in the building, right? There is also a little RS-232 cable, so I can be on the console of the Raspberry Pi in case anything really goes wrong. But I can also SSH into the Raspberry Pi via Wi-Fi from my laptop. All right. I could have put on Zigbee. I also have a Z-Wave dongle, and I have a software-defined dongle. The problem is that if I put all of those on there, I mean, you saw how crowded it was. Right? It's confusing as it is. Using just Wi-Fi as the example, it's just a wireless technology that at that point becomes invisible. Hopefully I answered that one. Let's see. Can I put it up onto YouTube? Yeah, I will. I'm still mastering the camera. Okay, so I do have some stuff for that, and it'll be under Computer Deconstruction Lab under their YouTube. Okay. Let's see. Comment about the Samsung and profits with things. And I was able to make money because they almost all the components and thus don't need to. Samsung directly profits from everything else on that phone also. Okay, so it's not just the making of the components. Okay, the stuff with SmartThings, they don't make most of it. So I mean, they do make refrigerators and microwaves and dryers, and they actually have the smart things in there, and it's going to have Matter. Okay, so like I said, Matter is a layer above the Wi-Fi and everything else. It's the protocol that defines how it exchanges the information. SmartThings has already announced they're going to have Matter. Okay, I'm hoping that it's open source enough where we can actually do this, in the Raspberry Pi and still be able to communicate with all this other stuff. And I can get rid of the SmartThings because my hub is going to go within the next 2 years. Is going to go end of life. Okay, and I really like to get as much of it out of the cloud as possible, especially when the internet goes down. I don't like the fact that I can't control things at that point. Okay, any other questions? Okay, so what I'm going to do, I'm going to show you something additional. The AI stuff, which is the Google Voice and the Alexa, the Siri, and all of that. That is something I didn't do a lot of research in here. I was trying to, but I do know something about it. Let me see if I can bring that up. Okay, so let us do it from here. I need my notes, which are underneath everything. Show. Start from the current slide. Okay. All right, so we got AI, which is artificial intelligence. ML, which is machine learning. Basically, machine learning is it takes all the data and it comes up with an algorithm. Now, algorithm normally means we understand what the algorithm is. In this case, no, it's something that the computer has generated within its internals, and I'll be honest, we don't understand this. Although MIT just recently did something where it comes up with an explanation of the algorithm, which is fantastic, because we really do need to understand what is being generated so that we can figure out its biases and stuff like that. All right, now the voice assistants. Voice assistants are a pain because you have to use the cloud with them. It's really difficult to use this stuff locally on your Raspberry Pi or a PC. It actually will consume a PC with a graphics card, okay? A big PC, like with a 3.3 gigahertz, one of the latest Intel processors. It'll consume the whole thing, processing voice. Now, this is one of my favorite XKD things. Like basically, hello, welcome to our house. Thanks for inviting us. Alexa, order 2 tons of cream corn. Alexa, confirm purchase. This is back to the security. The Alexa and the Google Home, basically anybody can speak, and it will take whatever it is. And if you programmed your card in there, it'll do the order. Okay, which is kind of scary. I do know that Google is supposed to have something that gets around that. I believe Alexa does too. I confuse both of them enough that I cannot get it to work properly. Maybe I talk too fast. I don't know. All right. All I know is that after a while, both Alexa and Google, they stop listening to me and they make stuff up. Okay. And I have had Alexa and Google argue with themselves. I set that up one day. It was quite hilarious to hear the two arguing back and forth about things. I also turned that off because it was quite annoying. Okay, so voice assistants. Oh, great. There we go. All right, so Google Assistant, Google Home, I think they've been merged, so they're the same thing now. Kind of. I mean, Google Assistant is actually on your phone. Google Home is the devices that sit around here, but they work together. Amazon Alexa, okay. I have the older ones that have the little switch on it to mute so they don't listen. The Google Home and the Google Assistant actually turn those things off physically. My cell phone, I accidentally left it on, and it has listened in on my conversations at the weirdest times. And then later on, when I'm going on to my web browser, I find that I'm now getting information about the weirdest things that we were conversing at the time. So I find that rather disturbing. Apple Siri, don't know much about Apple Siri. I don't know a lot of people who use it. Microsoft Cortina, I've turned it off on all my laptops because it's really annoying. Okay. And integrating it into your home automation, like Node-RED. Google Assistant, Google Home, and Amazon Alexa you can get that integrated, but it means it's going to go out to the cloud to process things. Okay? I have used it. It actually works quite well. I do get a little nervous as to what they're doing with my information and what else they're hearing. And one of the other things to note is that my employer does not allow me to have these devices in my office. Okay? I have to have them out of my office. My home office here, I'm not allowed to have them. They're always listening, even if I turn them off. Okay, so now we got the cloud. Okay, the cloud, basically anything you can run locally, you can run in the cloud. The only thing that you can't run locally, because generally you don't have enough horsepower in your computers, is a lot of the big data stuff. Okay, so anything where the machine learning requires a huge data set, which most of it does, although we're getting more of it moved to the edge where I think it's done part of the processing already, and they use sort of a algorithm that does machine learning and AI on the edge, and little processors. Okay, so small ARM processors. Okay, so we have if-then, IFTT. That's the gotten the meanings of that, but that's so you can interface to various other cloud services. It works quite well. I don't know what they're doing with your data. I think at the moment it's still free. I don't know if they have a premium service with that. You can get MQTT that exists in the cloud, so you can use it locally and you can use it in the cloud, or you can link them together. That way, you've got a connection from your local MQTT that signs up to the cloud. There's no hole, although anything that's published to the topics that you're listening to will get to your local one. Databases, software-defined networks. I mean, these things are becoming huge. It's the testing I do, by the way, at work. So you got Amazon, AWS, Azure, Google Cloud. You've got hybrid solutions. Some of this stuff is really interesting, and for home automation in the future, you could be using some of this. But I do worry about the privacy and who owns the information, and are they allowed to look at your information? Okay, when you've got corporate companies working with like Amazon, I don't believe they're allowed to. Does that stop them? I don't know. And if it's in China, okay, the laws for privacy there are different. I mean, what does that allow? Are they allowed in China to look at your stuff? I mean, that's a couple of questions I have, and I just don't have answers. And this is just the resource page. When you go up to the website, these links will get you to many of the things that are in my talk. If you've got any questions, you can go and email me, or you can go on to the CompDecon GitHub IO. That's the makerspace. Okay, and I have stuff there where I'm advertising what we're doing at the makerspace. Take a look and see if we have any more questions. All right, let's see. Can you create your own cloud service? Technically, you are creating your own cloud service by having the Raspberry Pi. If you're talking about the things like the AI part of it, yes, you can. You're going to have to start buying heavier hardware, bigger. You're going to have to buy blades and start putting them together. You can do this stuff at home. It's starting to get very complex because big data requires a lot of storage, right? For the vision stuff that they've been coming out with, before they actually had the good algorithms to determine dog, person, things like that, it required that you had terabytes of data, actually more than terabytes. And big data stores the stuff on multiple computers because there isn't one single drive big enough for this stuff. And one of the funnier things is that if you've ever formatted an MS-DOS drive from like 3.3, the rules for formatting a drive are exactly the same as formatting multiple disks across the internet. You've got clusters, you've got cylinders, you've got heads and stuff like that, and those represent the storage that you have out there. Right? Processing that big data requires big CPUs, a lot of them, a lot of processing power. It's not that easy to get it at home. Sometimes you can. Some of the newer stuff, they've done the heavy processing, and they've given you a sort of a sub-algorithm, right? And that allows you to put it onto smaller processors like the ESP32, an ARM processor, okay? and it allows you to do a little bit of the AI and the machine learning at the edge. Is what it's called. Okay, a question about where the edge exists. For some vendors, it's at the edge of their computing services. I prefer to think of the edge back into your house. Okay, right where you exit the, you get to the internet. All that's done locally there, not in the cloud itself. Let's see. Enough to have antivirus. I haven't even considered what antivirus would look like for an AI. I mean, now you're talking about, it literally could be a virus in the sense of a living virus running through the internet attacking AI and machine learning. The link to all of this, okay, let me go back here. Keyboard. I have multiple keyboards, okay, so I have an awful lot of keyboards. Okay, catch up with me. Computers never work fast enough for me. Wait, while that's going on, well, I don't have a computer antivirus. I don't have antivirus on my Linux systems, although I'm pretty careful about what I have on there. I am scared about some of the new malware and stuff that's running out there, and I don't have anything that would stop that. I'm trying to figure out how that stuff exactly works. All right, this QR will give you to the presentation where I'm going to put the information for this presentation later today. You'll have the entire presentation, including the notes, which you guys didn't see. Okay, and the resources will be at the end still. Okay. Samsung Bixby. Not familiar with Samsung Bixby. Let's see. Miss anything? Okay, Samsung Bixby, antivirus. Right, Anne, I'm not quite sure I'm understanding your question. On most of my computers, my computers are not exactly like yours, okay? Mine are not my laptop. I can use a laptop, but I build it up like a server. Okay, so everything, I remove all of the GUI software and stuff like that. I work mostly from the command line because that's what I do in my day job, okay? Which is not normal for everyone else. You have GUIs and stuff to make your life easier. You can put your home automation stuff on your laptop. If you've got a Windows machine, I would be very careful. This software does run on Windows. I am not familiar with running it on Windows because I've always used my servers, my Raspberry Pis. These computers are all headless. Okay? They have no video on them at all. In fact, no keyboards attached to them. They're all attached via the network, and I access them. My laptop becomes the dumb terminal. So the antivirus that's on there is plenty good for what I need. I just use an SSH connection across to my my home automation stuff. The web interface, that is just a regular web interface that's on each one of the devices that I have, and I can access that via my cell phone. And on there, it's basically some macros that I've created. Turn on the living room lights, turn off the living room lights, turn off all the lights, turn on all the lights, set a timer so that the lights will go off in a particular order, at a certain time from when I start the timer. Right, the rest of it is all in the scripts and stuff that I've written already. So sunset, sundown, open blinds and stuff like that. I'm working on open the windows, but I have a little problem with my window where the motor will torque it too much and damage the window. So I'll work on that. Other questions? Okay, I think we're done then.
Thank you so much for a wonderful presentation.
Thank you.
So just for everyone looking ahead, we're going to have a quick 5-minute break. And then at 1:30, we'll come back and the next talk will be about blockchains versus the right to be forgotten by Jeff Stolman. So we hope to see everyone there.
Hey everyone, welcome back. So our next presenter will be Jeff Stolman. He is a technologist with over 3 decades of experience working with a variety of technologies. He helps clients make sense of the technology puzzle and provides perspectives on both the threats and the opportunities of technology from varied disciplines. He's going to delve deep into new technologies to uncover the gotchas that don't get reported by the popular media. He's also a polymath with a passion for technology and skeptical nature that drives him to find ways to break it, and he helps more people solve the one or two technology problems that elude him. So without further ado, let us introduce Jeff Stolman.
Good afternoon, everybody. All right, well, our topic is blockchain versus the right to be forgotten. I don't know if that's a common term to many people, but it's becoming more and more important. It's a reference to privacy in the EU, where they've come out with a general data protection regulation. They call it the right to erasure. Basically, it's once you've got something out there,